Hi guys. So I think the reason why we are having this session is to help you with the themes about discount compound interest. Am I correct? The theme that you're going to be writing about?
Yes, doctor.
Okay, I'll just take you through the conceptual understanding of these terms, and I'm going to start with simple interest because you cannot talk about discount if ever you don't understand simple interest, because a discount is an opposite of simple interest. So I'll be just quickly taking you through the theory and then give you examples. Okay, I'm going to start quickly, just give you a quick or a review of simple interest, you know? And then compare it, because it's good if ever you compare those two, look at them parallel to each other. Okay, so for a simple interest, just basically the keywords that you find, or the critical aspects about simple interest, would be what is an interest. An interest is a positive thing. It's when your investment is getting a positive value, something that is positive. If you compare it to a discount is a negative thing. So now put your frame of mind into those two aspects. And then there's a simple interest. The simple interest is an amount that you get when you're calculating an interest. And then you've got a principal value, or that, and also they have a term, and then we've got a rate, an interest rate, and then an amount of your future value, and a due maturity date. That is the date when your investment is going to be maturing. Okay, there's also an aspect of timeline, and then I've also put the simple discount in a discount rate. All of these are the terms that you need to see them parallel to each other. Okay, so other critical aspects that you might be having, the issues. Okay, check out what is your common error. Is it because you cannot understand the formulas? Let us deal with those if ever you think you are having problems of understanding the formulas. Also, the substituting the correct values into the formula. The calculations can also be problematic. You don't know how to calculate, or you've got difficulties. And also, what is also very, very critical is translating from the word problems into mathematical expressions. That is where most of the people would find that they find it difficult just to read the English context and put it into a mathematical term. And also, there's an issue of time, when the time is compounding, and when the time is less than a year. What is it that we do? Those are the little things that you might think they don't matter, but they do matter. Okay, so let us start with the simple interest. The simple interest, this will be the formula that you'd find for simple interest. Sometimes you find it in this form. Okay, A here, sometimes called the final amount. I'm giving you these keywords in case you are reading from the context. So then you know when they're talking about the final amount, they're talking about the accumulated amount. That is the investment amount at the end of the period. And then you've got an annual, the interest rate is annual. Okay, it's quoted annually. You've got time in years, and then P will be your initial amount that you would put in. And then what is important here is that the interest is calculated per annum. Yeah? The term T must always be in years. This is very important. Or a fraction. What do we mean by a fraction? If ever you've got a shorter period, maybe a month or a day or a week, you must always divide by that unit. If ever it's months, you are going to divide by 12 months in a year. If ever you've got weeks, you divide the time with a unit of 52. If ever it's the days, you are going to divide by the number of days in a year. That's how you convert if ever you are given a time period that is less than a year. Okay, because the interest, it should be calculated. It should always be calculated. It should be calculated annually. So you are getting an equivalent value of the interest that is less than 12 a year. So here are the formulas that are very critical for you to know would I need to use these formulas? You've got a simple interest, which is PRT. This is one formula that you use. It will depend in the context. Okay, what is driving your problem solving is the context. The context will tell you what this is the formula that you can use. And then you've got this one for an accumulated amount. Okay, this one is a simple interest. Okay, the interest, let's say you invest 200 rand, né? And then your interest is 10%. So the simple interest will be 10 rand, the amount, not the percentage. Okay, and now you've got an accumulated amount, which is S is equal to P plus I. Sometimes it's written as A. Okay, I'm just giving you the different forms of these formulas, or sometimes the formula can be this. What is going to be driving you? It is the context that you're going to be working in. So let us, after the formulas, it's an example that follows. Okay, here you are asked to calculate simple interest. Already you go and open in your memory box AMA formula as a simple interest. That's it. As long as you are aware, what are the formulas that you need to use? So now you're going to be using simple interest formula, and then you are asked to calculate the simple interest. That means I, according to the formulas, and then sum accumulated and S for 5,000 borrowed. Okay, this is the amount. It is 4. That means this will be your principal amount borrowed 90 days. Can you see here? This is less than a year. Okay, so now if ever you've got less than a year, it means you need to, because these are the days. Okay, it means your time is going to be 90, and then you're going to divide by the number of days in a year, because this is less than a year. So this is going to be 365, and then you are told what is the simple interest rate. Okay, the simple interest rate, you've got the rate there. The simple interest rate, sometimes it's R or sometimes it's I. So this is 15%. So this will be 0.15%. No, it's 0.15. What you do, you take your 15, you divide it by 100. I'm going to highlight to you what can be a difficulty. A difficulty would be if ever you've got 5%. Okay, 5%, it is normally written as other people just write it as 0.5. Okay, that's a misconception that you'd find. So now you don't write 5% in this form. The best thing, take your calculator and say 5 divided by 100. I'm just highlighting little nyana things that you would find that would be problematic when you are doing these kind of calculations. Okay, we need to calculate for two things here. We are calculating for simple interest, and you are also calculating for this. So now there are two things that we need to calculate here. Okay, so now we start with a simple interest formula. A simple interest formula, which is I is equal to PRT, because we want to first calculate this one. Okay, so now what is your P? You know what is your P? It is 5,000. And what is your R? Your R is 0.15. And then your time is 90 divided by 365. Okay, you can just take your calculator, and then once you plug everything into your calculator, you'll find that your simple interest is 184.93. Okay, so now that is your simple interest, and then you are also asked to calculate ilento accumulated amount. Okay, you can go back to your formulas. Okay, here are your formulas. Here is the sum accumulated. It is P plus I. Okay, remember this one is either is I or it's simple interest. Okay, so now your sum accumulated is equal to P plus I. Okay, so now this is your I, that is your simple interest. So now your P is given to you, it is 5,000 plus your I there is 184.90. This is the simplest one. So you find that your accumulated amount is 5,184.93. Okay, that's one way. Okay, that's one way of calculating a simple interest. Let's say you want to use another method. Okay, you can use another method. I'm going to put it here. You can use another method whereby you know that your S is equal to P into 1 plus RT. That is another formula that you can use, okay, for an accumulated amount. So this is going to be 5,000 into 1 plus your R is 0.15 multiplied by what is important is the time. I think the emphasis here is just the time, how you convert the time. If you plug this thing into your calculator, you'll get your answer, which is this one. Okay, so this is simple interest. I just want you to have a feel of your simple interest, so then we can start talking about the discount. Okay, so if you are comfortable with a simple interest, without wasting any of the time of reviewing a simple interest, I'll just highlight to you how you read a question, because I want to spend time on simple discount and also compound interest today. So I'll just, when I get a question of simple interest now, I'll just highlight to you how do you extract the mathematics in the context. Here, determine. Yeah, but,
Yes, there's a part in the topic thingy where it says that the units used for the rates of interest and the term, they must be consistent.
the what?
It says that the units that are used for the rate of interest and the term, I believe the term is also the time, they must be consistent. So if the interest rate per year, then the term must be in a year or a fraction thereof. That was a bit tricky for me.
Is it tricky for you?
Yes.
Okay. What they are saying, check here. I'm going back here. Ne? Here, the interest is quoted per annum. That is a year. Ne? However, the time is quoted in days. Anish? So now we are happy with the interest. It is year. Ne? But this one is days. Ne? So now you are comparing the days against the year of the interest. That's why you need to convert the days, ne? The 90 days into equivalent year. So this is an equivalent period for a year. You take those 90 days and divide them by 365 days. So then you can get an equivalent a value of a year. So now this will be a year, although it's not written. That's how you would convert the days into a year. You convert them in this way if ever you've got days. So now you are working with similar units. Your days, your time is in years. Your interest is also in years.
All right.
Okay. So you will see when we are talking about quarterly, how we also make things to be equivalent. Ne? Are you good?
Yes, I'm covered. I'm covered. Thanks.
Okay. Here, I'm not going to do calculations, guys. I just want to show you how you extract information. It's always good to extract information from the context and then start substituting, okay? Here, determine the present value. They are looking for the present value. Already, you know the formula of a loan issued today with a maturity value. That is future value of this one. So this one is your future value. And then the time here is 2 years. And then your time here is 2 years. If the simple interest rate is 12 lento, here you are happy, okay? Here you are happy because everything is in time. Is in years, ne? Your simple interest is per annum, that is a year, and your time is also in years. It's not monthly, it's not quarterly. So I'm not really going to go and calculate, but I just want to show you this is how you extract information. So you are happy here. There's nothing you can do here. Just substitute into the formula and get what they are looking for. Okay, let's look at this one. Here you are. They say, Joshua, deposit 30,000 into a bank account that pays simple interest. 30,000 is deposited. That means your principal value is this one, okay? That pays a simple interest rate. Can you see? It's a rate that you are given here, a simple interest rate. So now this is your rate, okay, per annum. So your rate is per annum. How many years must he invest to generate? So you are looking for T here to generate. So this will be your future value. That means the sum accumulated. Also here, you don't need to convert anything. So all you need to do here, you can say my future value is equal to present value into 1 plus IT. You are looking for, you are given this one. This is 45,000. Okay. Your present value, it is 30,000 into 1 plus your interest rate is 0,075. Here's another one. The conversion of this thing is not 0,75, guys. Be careful. If ever you are unsure, take 7,5 and plug it into your calculator, divide it by 100 and see that you're going to get 0,075, and then your time, that's what you are looking for. Okay, I'm not going to do the full sum because I don't want to really spend time with simple interest. I want to spend time into discount and compound interest. Okay, so here's another one. This is a simple, at what simple interest rate? Here you are asked to calculate for OR. You don't know OR, okay? That should Lala invest. If she wants to grow 2,000, this is your principal amount, 2. This one, 2, is an accumulated future value in 5 years. So your time is 5, okay? So here, there's nothing that you need to do. Is just to go and substitute everything, and then you're going to have your S is equal to P into 1 plus RT. Your S is equal to 4,000, which is equal to your P is 2,500. 1 plus your R, you don't know, your T is 5. So here you simplify. It's just mathematically. I just wanted to, this will be a timeline. I'm not going to be spending time on simple interest calculations. I just wanted to see how you extract. I want to stay here. This is where I want to be. Okay. This is a discount. Obviously, a discount has got something to do with negativity. Okay. So what is a simple discount? Is you need to know what is a discount and what is a discount rate. Okay. We need to interpret the formula and also translate into timelines. Okay. So ilento discount is an interest rate calculated on the future value. Okay. Ilento is simple interest. Simple interest, remember, we had S is equal to P into 1 plus RT. We are wanting to go to the simple interest, is when it's calculated on the present value. Okay, with this one, it's the other way around. Okay, so you need to put these two against each other. Here are the formulas. Okay, if you can, just for revision, make sure you've got these two formulas against each other so then you don't make any error. Okay, so with a simple discount, here is a formula for simple discount. Compare it against the simple interest and see the difference. Okay, these two are different. So this one, it is calculated on the future value. Here is your S. Your S is your future value. This one on the present value. That's how they are different. Okay, the D will be the discount rate. And then the discount, the simple discount is an amount. Here you've got the simple interest, which is I. Okay, so you've got the discount rate is a percentage, the interest rate is a percentage. Here you've got the sum accumulated. Here you are talking about the principal value. The time, it is still time. The time, it is still time. We still follow the same procedure. The time should be in years, and and if ever you've got a time that is less than ulento, is less than a year, you have to divide it by the unit of that time to convert it to become an annual an annual time, a year. Okay, so you still follow the same procedure. What I want to highlight here, it is just the formulas. You've got this one, you've got this one. Okay, this is what I want to also warn you. Your simple discount is not S is equal to P into 1 minus DT. It is not this, okay? Because there's a tendency of wanting to write a simple discount in the form of a simple interest. Watch out for those, okay? There's also another thing that you also need to be aware of. A simple interest net discount, they are operating the same way. One is positive and one is negative. Okay, you can get an equivalent rate. Okay, if ever you've got a simple interest, you are quoted a simple interest net discount. Okay, if you've got a situation like that, and if you've got a situation like that, what you need to do, you need to be aware. Oh, so if you've got a simple interest net discount on the same situation, here is the formula that you use. This is a simple interest rate that is equivalent to a discount rate. If you are given a question that is requiring you to use the equivalent discount rate given a simple interest rate, or you are given a discount rate and then you need to calculate a simple interest rate. This is the formula. I am not going to go through on how it is derived. This is a process of deriving it. What is important, you need to take this formula and run with it. We are going to be using this formula for equivalent rates, simple interest and discount. Okay, so here is a question for a simple discount. Okay, so the question is saying determine the simple discount. A simple discount, remember, it's not a rate. According to our formula here, a simple discount is this one. You need to find this one according to our formula. Okay, we are not looking for a rate. We're looking for the actual amount. So now a simple discount, we must look for D on a loan of 3,000 due in 8 months. Okay, this is a loan. This is a loan. Remember, a discount is calculated on a future value. So now this is your future value, or S. Okay, this is due in 8 months. Your T here, if it's 8 and then it's months, you need to convert this thing to become annually. So you're going to take your 8. How many months in a year? You divide by 10 because your time period is less than a year, it's months. So you divide by the number of months in a year, so then you can get an equivalent amount, the equivalent time, which is quoted annually. Okay, at a discount rate, here is the rate. So your discount rate is equal to 0.15. Okay, what is a discounted value of a loan? A discounted value of the loan is a present value. These are the keywords that you need to remember. When they are talking about the discounted value, they are talking about the present value. That is another name of a present value, or the principal. So we are asked to calculate this thing. Okay, what is an equivalent? Okay, you are asked 2 things here. Okay, there are 2 things that are being asked here. Okay, you are asked first to get a discount. Okay, and also a simple discount, and also you are asked to get an equivalent. Remember, I said if you've got a context whereby there is a rate of a discount, and also there is a rate of an interest rate, you use that formula. I'm going to pull up the formula when we get there. The formula that you can use, we are going to use this formula. that is R is equal to D over 1 minus dt for an equivalent rate. But now let us first calculate the D. We need to find the D. Okay? So how do you calculate the D? The D is equal to, so now your D formula is equal to SDT. What is your S? Remember your S or your future value, it is 3,000 because a discount is calculated on the future value, that is 3,000. It is due in 8 months. You can even tell from the context that this is something in the future. Okay, so now you've got 3,000. And then how many day, what is your discount rate? Your discount rate is 0.15. Okay, and then what is the time? You've already converted your time to become annual. So you take and plug into your calculator, you find that your answer is 300. Okay, so once you've got this, okay, you are asked, remember, you have to calculate for UD. There are three things actually here. You've got this one, you still need to calculate for your present value. So you go to your formula sheet and say, what is a present value given the context? The present value using the discount, this will be the formula that you can use. Okay. Then you come here and say, okay, fine, let me calculate my present value. My present value is equal to S minus D. So what is your S? Your S is equal to 3,000 minus your D, you've just calculated it. It is equal to 300. So this is going to be 2,700. Okay, so you've got this one. You need to calculate an equivalent simple interest. Okay, so we said for that, we know our formula that we are going to use. We'll simply use this formula and say, okay, for our equivalent rate, we are just going to say, we know what an equivalent interest rate of a given discount is equal to 1 minus dt. Okay, and then you are looking for your R. What is your D? Your D is equal to 0.15 divided by 1 minus, what is your D? Your D is 0.15. And then the time here, your time is equal to, you're using the very same time because you're looking for an equivalent interest rate. This is 8 divided by 12. So what you do, you can just plug this thing into your calculator. Okay, when you plug into your calculator, you will get that this implies that your R is equal to 16.67. Okay, that is your equivalent interest rate if you are calculating an interest rate when you are given a discount. For always remember this formula. Okay, you don't need to stress and look for things that trying to derive things. Here is a formula, it's already been derived for you. All right, let's look at another example. Still on the discount and also a simple interest, because these most of the time are asked almost the same time. It's either you calculate a simple interest alone, the context of simple interest, or you've got a simple discount alone, or you've got questions whereby these two are brought together at the same time. Okay, so make that distinction. Okay, here's another example. They say a loan of 5,000 must be paid in 6,000 time in 6 months time. This is done in the future already. You can tell what this is your your S, that is your future value, because they tell you what this thing must be paid in future. That means it's a future value. And then your time here is 6 months. Again, your time is equal to, is less than a year. So you're going to take your 6 and divide it by these by 12. If ever it was days, you're going to divide by 365. Okay, we'll see when you are doing compounding interest, whereby we are getting the compounding time. Then we'll divide by that. I'll take you through when you get to compound interest. Okay, determine the amount you will receive now. That means we are looking for the present value, the amount you will receive now. So now we are looking for a present value. If the simple discount, né? If the simple discount, that means your little d is equal to 0.18. And can you see your discount rate? It is quoted per annum, so you don't need to change anything. You've already taken care of this one. So you have to get your P and then determine the equivalent. You also need to calculate your I. So you've got two things that you need to calculate here. Same thing, you take your formula and say, I'm going to calculate my D first. So my D is equal to S dt. So my S is equal to 4,000. My D is 0.18. My T, I've converted it into an annual period. This is 6/12. You plugged it into your calculator, and then your calculator will give you 360. What is your present value? Your present value is equal to S minus D. So your S is equal to 4,000 minus 360, which is equal to 3,640. So you are done with that part, and then you are also asked to calculate the equivalent simple interest. That is simply, you've got your R is equal to D over 1 minus dt. So now your D is given, it's 0.18 over 1 minus 0.18. Your time, you use this time, which is 6/12. You plugged it into your calculator, and then this is going to be equal to 19.78%. Okay? So if your interest rate was compounding in a different way, you'd have to convert it, but I will show you how you do that with a compound interest. Okay? So those are the two aspects that when you look at them at the same time, that is simple discount and also simple interest. Okay, so now we are going to come now and look at compound interest. Okay, because that's where we always get a lot of misconceptions when we are working with e-compound interest. Okay, e-compound interest, it is normally written. If maybe you would Google, you find that this will be a compound interest. Is when you've got an exponential, your thing is raised, your t is raised to the power t, and then this one is in this form. I will take you through. I want us to use this one. Even if your thing is compounding annually, it does not matter, but I will take you through the formula. So also the same thing, your N is the number of times the interest is calculated. The interest may be compounded. Né? When we are talking about compound interest, remember the interest rate that we were calculating for simple discount and simple interest, it was not compounding. It was only the time that was short. But in this case, your interest can be compounding. Okay, you can get that your interest is compounding biannually. That means it is compounding twice per year. Okay, or your interest, it is compounding semi-annually. That is twice a year. Or it can be quarterly, that is 4 times per year, or monthly, that is 12 times per year, or daily, that is 365 5 times per year. It depends. So these are the kinds of things that you need to be watching out for when you are reading the compound interest calculations. Okay. And then here is the formula. It's a compound. Here is a formula that you would normally find on compound interest. And I'm saying now, most of the time the interest is compounding so many times. Okay. So now we are saying here is a formula that we need to be using, whether it's compounding once or 3 times or 5 times, we are going to be using this formula. This formula, we are saying your interest rate is compounding so many times, that is M. And then when you convert your interest rate, you must also convert your time. Okay? So then you are working with 2 similar units. So now we are saying for your N, we are going to take the number of compounding times. If your interest rate is compounding monthly, that means your M is equal to 12. You are going to multiply your years with that compounding period. Okay, so we are going to be using this formula. Let us go through the examples so then we can see this compounding thing, how it works using this formula. And then you've got a compound interest, that is an amount. It is this one. It is similar to the one that you saw when we're using a simple interest. Okay, here's the first example. Okay, we are saying now find the compounded amount on 5,000. The minute they say a compounded amount, you know they're looking for the future value. A compounded amount on 5,000, that means your present value is equal to 5,000. Okay, invested for 10 years. Okay, for 10 years, your T here, it is 10. Okay, your T there is 10, and then you've got your interest here. You can see your interest. Your interest is per annum compounded annually. Okay, so your interest here, it is 0,075. It is compounded annually. When thing is compounded annually, your M is just equal to 1, because annually is once. So now I want us to follow the formula. So we are saying now the formula is equal to P into 1 plus I over M over MT. That is your N. So therefore, your N is going to be equal to your M times T. What is your M? The number of compounding periods multiplied by your T. Your T there is 10, which is equal to 10. I want us to use this formula so then we don't move between a formula which is not compounding. We stick to this formula. So now your present value is 5,000 into 1 plus your interest rate there is 0,075. This is 0,075. You divide this thing by the number of compounding periods, because this thing is compounded annually, which means it's 1. So you've got 1 to the power, your MT is 10 multiplied by 1. So you can just plug this thing into your calculator, and then you would get the answer of 10305.16. Let us vary these examples and see when things is compounding in a different period. Okay, here is another example. Okay, how much interest is earned on 9,000? Okay, on 9,000 invested, on 9,000 invested for 5 years at 8% per annum and compounded annually. I am not going to go through this question, but I'm going to be varying to highlight to you what is it that they are looking for. Here they are looking for your I, that is the interest, not the interest rate. That is earned Okay, on the present value, this is your P. Your P is 9,000, okay, which is invested for 5 years. Your time is annually, and your interest is compounded annually. So now your I is equal to 0.08. When something is compounded annually, it means your M is equal to 1. Okay. So now you can just go and plug into your calculator and find your accumulated amount. So now we are going to have your S here is equal to, therefore your N is going to be equal to 1 multiplied by 5, which is equal to 5. So your S is equal to P into 1 plus I over M into to the power MT or N. And the answer then is going to be 13. Are we still together, Mara?
Yes,
2,
two,
13
three.
to 3. Did you get the same answer as this one?
Yes, ma'am.
Okay. So after you've got this one, you still have to find your I. Remember, what is your I? Your I is equal to S minus P. So your S there is this one, that one you just calculated, 13,223,93 minus your P is 9,000. Then you get your answer to be 4,223.95. That is in simple terms the compound interest. I just want us to look at the one which is compounding so many times. Okay. So here you've got 1,000 is invested for 1 year. Okay. 1,000 is invested for 1 year, 8% per annum. Ne? But the interest is compounded semi-annual. Okay. So now P, this is your P, is an amount that is invested. So your P is equal to 1,000. Okay. You've got your interest rate here. Your interest rate, it is compounded. It is 8%, but this is compounded so many times. So it is compounded semi-annually. We know from our notes, if something is compounded semi-annually, so now it is twice per year. Okay. So now once you've got that, this thing is twice per year. So it means you are going to take your interest, and then you are going to take your 0.08, and then you divide by the number of compounding periods, which is I don't want to do that now. Let's not do that now. Our interest rate is 0.08, and then the number of compounding periods. Remember, M is for the compounding periods. It is semi-annually. It is equal to 2. Ne? And then how much interest is earned, we are asked to calculate for OI. Okay, so now we first need to calculate, we just need to calculate for the interest, but we cannot calculate for an interest. We first need to get the accumulated amount first. Okay, let us get the accumulated amount. So now we already know what is it's a compound interest formula, because it's something, interest is compounding. So now your S is going to be equal to P into 1 plus I over M into M multiplied by T. Okay, so now your P is equal to 1,000 into 1 plus your interest is 0.08 divided by the number of compounding periods, it is 2, and then your M is 2, your T, where's your T? Where is your T? It's 1 year. Here's your T. It's for 1 year. So your T here is equal to 1. So it's 2 multiplied by 1. Okay, so everything is in similar units. It is annually. Your interest rate has been taken care of. It has been put into an annual rate, and also your time is annually. It's in years. So you just take and plug into your calculator, and then you will get the answer of what is an answer here? You will get the answer of 1081,60. Remember, you were asked to calculate for an interest. You know the formula for an interest. Your interest is equal to your S minus P. So your accumulated amount is 1081 minus dot 60 minus your P is 1,000, which is equal to 81 rand, 60. Okay. I'm not really going, I'll just do, okay, we're not going to worry about OM. If ever you determine the accrued principal, if the interest is calculated, I want to highlight in the buyer interest here, okay? Here, your T is in years, so you've got your T is 3, okay? So your interest is equal to 0,14, and then your P is equal to 2,000. Okay, but now there is a compounding. When something is compounding yearly, we know that is your M is equal to 1. Okay, when it's compounding half yearly, we know Uguchi, your M is equal to 2. That is semi-annually. When it's compounding quarterly, we know that your M is equal to 4. When it's compounding daily, your M is equal to 365. Let us get an example of this one. Okay, so now if we were to do the calculation, what is it that we have to calculate here? We need to calculate an accrued principal. An accrued principal is your future value. Okay, so your accrued principal would be your S is equal to P into 1 plus I over M to the power MT. Okay, I am taking this one. Okay? So your S is equal to your P is 2,000 into 1 plus your interest rate is there. It is 0,14. It needs to be converted into an annual rate by dividing by the number of compounding periods, which is 4. So you're going to have your 4. Here you're going to have 4 multiplied by your T is 3. Okay, you multiply it by 3. Then you can just get your answer. This is going to be 1 plus 0,14 divided by 4. Where's my calculator? I did not calculate this one. I just found it. Hey! So you've got 0,14 divided by 4. This is going to be 0,035. 0,035 to the power 12. Okay, you can get an answer. I just want you to see how you do these things. If ever the thing was compounding daily, instead of here, your M, you would put your M to be 365. Your T is still the same, so then you don't lose. You need to be consistent. You must be gentle with your brain cells, not to change when you're in a different context. If ever you are compounding annually, your M is going to be 1. You substitute your 1 here, and then your T is still the same T. It has never changed. But when you are integrating it into your formula, that's when you are going to have a different exponent. All right. Here is I've varied this example. Okay. In this example now, we are looking for the present value. That means a discounted value. Sometimes a present value is called a discounted value. I'm giving you these keywords. So then when we get to those heavy questions, because we are going to be looking at the heavy questions whereby it's difficult to navigate, to decontextualize. You must know these keywords. So now we are looking for the present value. We don't know what is our P. If the compounded amount, that is the future value, you are told, it is clear, your compounded amount, that means your S is equal to, let me not write S as if you say Lantiga, your S is equal to 10,000, is invested at 18%, so your I is equal to 0,18 per annum for 5 years. Your T is equal to 5, and the interest is calculated monthly. That means it is compounding. It is compounding monthly. That means your M is equal to 12. You are looking for what? For P. Okay. So what do? Go and grab your formula. Always, your S is equal to P into 1 plus 1 plus I over M to the power MT. Same drill. So now your S, is it drill or what? Same drill or grill, I don't know, whatever it is. So your S is equal to 10,000 is equal to P into 1 plus, what is your interest rate? It is 0,18. What is your M? We have said it, our M is equal to 12 because it's compounding monthly. You've got 12 to the power. Your M is 12 multiplied by 5. Okay, so what is left here? It is just to simplify here. Simplify whatever is inside. What is this? I don't know. 0,18. Okay, you've got 0,18 divided by 12. Okay, plus 1. This is going to give you 1,015, okay, to the power 60. Okay, to the power 60, and then this is 1,000. So you can just have your 1,000 into 1,015 to the power negative 60. Which is P. You are just taking this whole thing to the left-hand side. Just take a negative exponent because this one is a reciprocal. So now you plug this thing into your calculator. This implies that your P is equal to...
Okay, ma'am.
Yeah, boy.
It's not 1,000, it's 10,000.
10,000. Okay. Thank you for that. Okay, you can just plug this thing into your calculator, and then you find that your answer is 4,092,96. Okay, so now what was critical about this question is that we are not calculating for a future value this time around. We are calculating for the present value. You stick to the same process. Get your formula. Put your formula out there, substitute. After you have substituted, then you can do your mathematical manipulation. Okay? Don't simplify your formula before and then want something that is simplified. Anyone who's got a question?
Yes, Doc. I missed the last part.
Okay, I'm coming now. The last part, you know? Are you fine here?
Yeah, there I'm fine. There I'm sorted.
Are you cool here?
Yes, there is.
Then from here, you plug into your calculator, Ngish?
Oh, okay.
Are you fine there? You take your calculator, you've got your 10,000. My emulator is not working on this tablet, so I cannot put my emulator live so then you can see how you plug. You take your calculator and then you are going to multiply it 1,015 to the power negative 60. Yeah? Your answer is 4092,96. Remember, we've got an accumulated amount. We've calculated it. We have calculated for our present value. Now, how do we calculate for our time? Okay. At time, we need to include our logs. Okay. So now this is very critical. Now, our issues are not only to make our units of finance, our issues are our logs, because we are dealing with exponential equations. Okay, let's not worry about that right now. Let's see what is it that we are given. Let's look at the story. After what period of time? We don't know. After what period of time will 2005 double? That is a will. So now it means your present value is equal to 2,500 now. Okay, will in the future, that means in the future we've got your S. This is going to have doubled in the future, which is 5,000, is 2.5 multiplied by 2. The future value is not explicitly given. It is implicitly given. You need to be able to read that from the context. Okay, if the interest is calculated half yearly, you've got your interest is calculated half yearly. It is compounding half yearly. That means it is compounding semi-annually. It is compounding twice. That's what half yearly means. Okay, that means it is compounding. If it started in January and then it's January until June, that is a half. You've got the first group, and then you start again from June to December. So you've got two groups half yearly. So that's why you've got M is 2. So your interest is compounding twice. And your interest is equal to 0,11. Okay. We need to find the time. Okay. Always, always, forever, you get your formula. Okay, so your formula is your S is equal to P into 1 plus I over M P. What is your S? Your S is 5,000, which is equal to, what is your P? Your P is 2,500 into 1 plus your interest is 0,11. It is compounding half yearly. You divide it by 2, and then you've got 2. What is your M? Your M is 2. You don't know your T. That's what you are looking for. Okay, so now you can just divide to 5,000 go lento. 5,000 go 2.5. You will find ukuthi that is equal to 2. Ne? That is equal to 2. You right? Ne? 5,000 divided by 2,000. Yeah, I cannot do arithmetic, guys. You must never trust me. Arithmetic is better. So this is equal to, okay, whatever is inside is going to be 1,055 to the power 2t. Okay, this is an exponential. I'm going to get out of this discourse and go to logs. Let's get out of here just a little bit. Go out and say, we know, good thing, if you've got y is equal to ax, this is a pure logs. Okay, this is the same as this one. It's an exponential equation. So if you want to solve an exponential equation, you use the logs rules. So according to the law, it's saying you can get an answer and say your x is equal to a log of whatever you find here. Okay, whatever log you find here divided by the log of this base. That is the property. Okay, it is the gospel truth. That's what the mathematicians are telling us. It is so. And I wonder if there's anyone who ever asked them, Munguti, why are you saying it is so? You know, in mathematics is one of those subjects that really, the mathematicians sometimes they bully us. You are told good, this is what it is, and then really we have to swallow it. So we have to swallow it. This is the method that you need to just accept good, it is true. Okay, so we are going to take this formula and accept it and say, let us take this formula and apply it in our context. Okay, so if we were to apply this thing into our context, we are going to say this is our exponent, this is our x. So we are going to have our 2t is equal to a log of whatever we find here, which is 2 divided by the log of 1,055. This is according to this gospel truth, this truth of the mathematicians. Okay, so you just take your calculator. Okay, you first find your log and divide a quotient. This divided by this, you can just get your calculator, get the log of that, and then divide by that. And then you, after everything, you divide everything by 2. Okay, so take your calculator. Take your calculator and have log 2 divided by log of 1,055. Okay. After you have done that, you divide by 2. So therefore, your t is going to be equal to 6.47. I'm going to wait for you guys and see if ever you got the answer. And then after that, okay, I think I'm not going to do this example now because we've already gone through the equivalent simple interest and when you've got a simple interest and also a discount rate. I've already attended to these ones. I think what is important here is to look at the exam equivalent questions, because at the end of the day, we need to know how to work with these, how we work with this. Or perhaps I should get another question which is similar to the one that we've just done. Okay. So then you can see what these things that's actually a repetition. It's just that it's just the context that will change. Okay. So the question is saying, find the number of years. Okay. We are looking for t. Okay. That it will take for this amount. Okay. It will take for this present value amount. Okay, to increase, that will be an accumulated amount. That means your 748, okay, is going to increase by 72%. So we are saying 748 is going to increase by 72%. Okay. If you don't like this, you can say 748 multiplied by 72%, and then you take that value and add it to 748. That's what we are saying here. 748 plus 748 multiplied by 0,72. So the accumulated amount then is going to be 1286,56. Okay, so that will be your accumulated amount. So don't confuse this 72%. I mean, there's no way that you can ever say an interest at 72%. So the minute you start making that mistake, you must question yourself, where have you ever seen that in reality? So you check where you've done a mistake. So your interest rate of, so your I is equal to 0,079. Can you see here what would be a common mistake? Would be to write this thing as 0,79. Those are the common misconceptions that you can easily fall into. Okay, be careful. Okay, so now your interest is compounded semi-annually. So your M is equal to 2. Okay, I'm not going to calculate this thing, guys, because I've got things that I need to discuss with you. So this is 748 into 1 plus 0,72. So the answer here is 1286,56. So similar process, your S is equal to P into 1 plus I over M MT. What is your S? Is 1286,56 is equal to, your P here is 748 into 1 plus, what is your interest rate? It is 0. This is incorrect, guys. I just wanted to highlight the common error. 0.79 divided by, what is our M? Our M is 2 to the power. What is your M? Your M is 2. You don't know your T, so you're going to have 2T. Okay. So you are going to have 1286 divided by 748. So that is going to be equal to 1,72, which is equal to what you find here. You're going to get 1,0395 to the power 2t. You apply the logs. The logs are saying your t is going to be equal to log 1,72 divided by log of 1,0395. I'm not going to finish off the answer. You can just see this thing is a repetition. Okay, this thing is repeating itself. Let us see other interesting things, because now I think the problem with this is how do you read this thing into a mathematical expressions. Okay, when I see that the question does not need much, I'll just show you how you extract it, because that is the main thing. There's too much English going on. We get lost in the English. Then there's mathematics. So the best way is to read the question. This question is saying Nola invest 15,000 into an account. So she is investing it now. So you've got your P is equal to 1,500. She is doing it now. Invest, that is a present tense. Okay, invest is a present tense, earning this amount. So your interest here is equal to 0,0657. Again, don't run into a trap of saying your interest rate is 0,657. These are the common errors that you find. Be careful. Okay, you don't do it like this. Okay, the balance in the account 16 months later. Okay, we are asked to find our S. Okay, look at the time here. The time is not written in terms of in terms of a year. So now we are going to have your 16 divided by 12. So then you can have an equivalent amount, which is a year. Okay, I'm not going to calculate the answer here, guys. I just want to show you how you extract and simplify your mathematics from the context. Let's look at this one. Okay, what is this? A bank discount rate. Okay, a bank discount rate is 12%. So now your D here is equal to 0,12. You need to pay the bank 5,000. That is your future value. It is equal to 5,000 in 6 months' time. Here is the time. Your time is less than a year, and then it is in months. So you're going to have your T. Your T is going to be 6/12. Okay? So the amount of money that you will receive now from the bank. So now you are asked to find your P. Okay, so I'm not, this one, it is simply straightforward. So what you need to do is to get your formula. You are working with a discount. Yeah? This is the context of a simple discount. So you would need to get the formula for a simple discount. The formula for a simple discount. Hello? Your formula for a simple discount is 1 minus dt. Okay, you are looking for P, your S is 5,000 into 1 minus your discount rate is given to you. It's 0,12. Your time, this was what is critical about this question. It is 6/12. Okay, I'm just highlighting things that are critical in the question. The rest, you can just do the mathematics and get the answer. Okay. Let's look at this one. This one, she borrows this amount from the bank at an interest rate of 26% per year. I wonder which bank is that one. I want to go. Sure, that's a lot. No, I don't want to go to that bank. That's too much. I thought it was the money that it was an investment. So you are borrowing the money here. So now that means your present value is equal to 7,500. Okay. At an interest rate per year, this thing is compounding weekly, guys. Ne? So here, your interest rate is equal to 0.26. Ne? However, it is compounding weekly. Remember from our table there, when something is compounding weekly, your M is equal to 52. Okay, that's a conversion rate for weekly. The amount Freda will pay will pay the bank after 72 weeks. So now your time here is also given in weeks. So now you are going to have 78. You are going to have 78 weeks. Okay. Now, let's talk, guys. Let me get the formula. I want to hear from you. Your S is equal to P into 1 plus I over M into P. Okay. I want you to, I'm going to substitute. Let me substitute. So then we can talk. I want you to become the teachers. What is your M? It's 52. Your M let's talk about this creature. Is this correct? Let's talk. Because here, what I've just done was just to substitute. Following the same process, is this correct for me to take the 78 weeks and multiply it by another 52 weeks? Am I correct there? Is there anyone who wants to comment by saying yes? And maybe why?
I think no.
Why?
It's correct, but it's not correct. It's correct, like it's not correct because when you substitute on M multiplied by T, M is 52, while T is 78. So you must interchange them.
Pardon?
You must take the 52 to the left-hand side, multiply by 75, 78. It's like we substituted with M is equals to 78 on the formula.
So I should write what?
52 multiplied by 78.
No.
You still get the same thing anyway. That is called associate.
It's correct.
It's an associative property. It does not really matter. What you are saying, AB is equal to BA. It does not matter. You'll still get the same thing.
Okay.
What is it here? Would you say it's correct if ever you are a teacher and say, yeah, this is correct because you have substituted correctly?
That's why I said it's correct, but it's not correct.
Because of this, but okay, I'm going to say
how
it
you
does not
substitute
matter.
it, but
If
the
we're
answer is
applying
correct.
this, it is fine.
Yeah.
Okay. I'm going to say to you, be careful. What are the units that your time is given? Okay, so then you don't get in what we call a circular argument. Just because you've been doing it like this, you always want to do it and get into a misconception of of a misconception of what is this misconception of substitution. Okay, here our time is already converted in weeks, guys. Okay, the only thing that was a year here was only a rate. So a rate has been taken care of. We are done with the rate. This one has already been done for us. Okay, it has already been done for us. So we don't really need to be stressing ourselves. Okay, because if your T was equal to, if your T was equal to years, you'd have to convert it to weeks. But everything is in weeks here. You've got weeks here. We have converted this one. This was the problematic one. This was compounding weekly, okay, but it was per year, but compounding weekly. You needed to first convert it so then it can reflect the weeks, which is already the weeks here. So now here, your time is fine. You don't need to be multiplying by 52 because it's already in weeks. So you leave it like that. Okay, the only thing that needs to be converted in this context is only the rate because it is per year, but it is compounding weekly. So we need an equivalent rate that is weekly, which is this one. This one has already been done for us by whoever was setting the paper. That's what I'm trying to say here. Uguti, this is already your M multiplied by your T. It's already been converted for us, this one. Okay. So you don't need to proceed. So hence I'm saying, check what is it that you are given. Do you need to convert for the sake of converting? Your time is already here in the weeks. Okay. So now you'd have to proceed and get the answer. Okay, that's what I wanted to highlight there. Okay. Let's look at this one. This is for the accumulated amount. I'm not going to look at this one. And investment of this has accumulated to this one. I'm not going to be looking at this one. I'm looking at the time. Okay, I'm looking at the time. So here you've got an investment P. You've got an accumulated amount, which is S. Here you've got a simple interest. Okay, you are looking for your T. So you just substitute and find your answer. It's a simple interest formula. So I'm not going to be looking at this one because we've only are left with few moments. Okay. So let's look at this interesting one. Okay. Because this one will force us to do a timeline. Ne? Miriam bought a painting. Yeah, a painting of 15,000. Okay. Ne? She bought it whenever that it was that present moment then. For 10 years, the value of a painting increased by 20%. Okay, it has increased by 20%. Thereafter, the value increased by 15%. So now the interest rate has increased twice in this situation. The amount of money that Miriam can expect to receive if she sells the painting after owning it after 23 years. Okay, here we are looking for a future value. The only way that you can be able to follow the story is to write your timeline. That's the only way, otherwise you will never make it. Okay, no, let's write the story in the timeline. Okay, now this woman buys ilento, buys a frame. That is your present value. This is your first present value here for 15,000. Okay, that's what happens here. Okay, so now this thing continues for 10 years. Okay, for 10 years, this is when your N is equal to, your N1 is 10 years. For 10 years, this thing has grown. Your interest rate in this period is equal to 20%. So your I1 here is equal to 0.20. Okay. This thing, obviously, it would have accumulated to a specific amount. Ne? This is only for this period. After 20 years, what is an accumulated amount? Okay. So when you are starting again here at this period, this thing is the total amount of your investment is 23 years. Okay. So now, if ever you've got 10, and then from here, N0, this is your N0, from N0 to N23. So this is your TN, this is equal to 23. That is the full amount. But this thing has run from here, from this point to here is 23 minus 10. So here, your new amount here is going to be equal to 13 for this period from here to there. Okay, that will be your second part. Okay, so now you are told, Guti, the interest rate thereafter increases again. You've got this, your second interest rate. Let me have a different pen. You've got your second interest rate here. We are told, Guti, it is 0.15. Okay, and then you don't know what is your accumulated amount in this period. So you've got two periods here. Okay, so now what you need to do is to first calculate for this part. After you've got the accumulated amount, you've got a present value which you are going to move for 13 years, going to the end of your investment period. So now you first need to calculate for this period. Okay, for this period, your accumulated amount, okay, is equal to, right, is this a compound interest question or a simple interest question? Is it a compound interest formula, a thing, or it is a simple interest question? Is there anyone who wants to suggest whether this is a compound interest or simple interest? Because I can just go and get a simple interest because it's not saying anything. Is there anyone who wants to comment? Uguti, is this a simple interest or a compound interest? Because it's important to know which formula to get.
If I'm to
compound interest.
Pardon?
A compound interest.
Why?
Because I think if you check there, we have received interest twice. I think since we have received interest twice, then because simple interest is just it's getting interest on interest. So I think it is compound interest.
All right. Let's only focus only on this period. Let's assume that we don't know this. Okay? The information I was telling we know nothing about this thing. The question is saying Miriam bought a paint for 15,000 for 10 years. The value of the paint increased yearly. And then what is the accumulated, what is the final value?
I think we can use normal simple or compound.
Assume ukuthi ayikho le information asiyazi abasitshela next. Ngifuna ukuyicima ukuthi ningayiboni. This thing does not exist as far as we are concerned. This little part, would you say this part is a simple interest or a compound interest? Let's hear. How can you tell ngoba abatsho? And then you need to make a decision, but okay? Is it difficult to tell which formula to use?
Well, in this case,
You can use anyone here.
Let's use compound.
Why? Why? Remember, this is time value for money. You need to be able to take into account these things. Let's read the question. Umire muthenga painting, bantwana basekhaya. Yeah, 15,000. That is your present value. We are happy with that. We don't have a problem with that. Okay. This thing, it ran for 10 years. These are the 10 years. It's running. Within this 10-year period, it is increasing yearly, every year increase interest 20%. That means within the 10 years, okay, within this 10-year period, this is 0, this is first year, this is second year, this is third year, fourth year, fifth year, sixth year, until the 10th year. Every time, increase of this thing on 20%. Increase on 20%. Increase on 20%. Increase on 20% every year.
No, I think
it's compounding.
It's compounding, yeah.
It's compounding yearly. It's compounding yearly. Therefore, your M here is equal to 1 every year. You can't just say it's a simple interest. It's simple interest. We are telling you invest now, and then your interest is going to earn interest 10% for 10 years. If ngale 10 years is earn interest 20%. That's it. So you interest 20% in 20 years once. Mara lena iti yearly uyatshela ukuthi it is increased. Yakhuphuka every year. That is compounding. It is compound. Remember, compounding is something that is doing something consistently all the time, every year. That is compounding. Okay, that's how you read, guys. You read this kind of information, so then you can be clear. Ukuthi, are you sitting with a compound interest, or are you sitting with a simple interest? Okay, the simple interest rate is once off. Yeah. So this is a compound. So this part le part lena, it is simple interest. So your S is going to be equal to P into 1 plus I over M to the power MT. So now your P here, your P is going to be equal to your 15,000 into 1 plus your I is 0,20 over your M is yearly, that is compounding yearly, is once. And then your M is 1 multiplied by your T. Your T is equal to, here your T is equal to 10. So now this is going to be 10. You plug this thing into your calculator. You'll find that your thing is going to be equal to 9.2. That is your S1. We are calculating for our S1 here. Okay? So your S1 is going to be 92870. 6,05. Okay, ilento final value here. Then here usaqhubekeka une second period futhi awuqala lana, you are starting with another value. The value ozoqala ngayo, which becomes your present if you were starting here, is going to be this very same value. So this one is your S1. At the same time, it becomes your P2. Okay, it becomes your present value for this new period. Now we are looking at this new period. Okay, now we have to take this period. Okay, now there is this period. Why ngithanda green bantwana iyangibhora green? Let's get it purple. So now let us start again for this period. As we start again for this period, siqala lana with a new amount, which is this one, and then end here. So we still do the same thing using this very same formula. Okay, so now we are looking for our S2. Our S2 is going to be equal to, what is the present value for this period? The present value for this period will be this final value of the previous period, which is 92876.05. I'm sorry, guys, it's space. So your S2 is going to be equal to 92876.05 into 1 plus. Nalana, the second time is also, you are told good is increased yearly, is also compounding. M is equal to 1 also here. Is compounding yearly, your M is equal to 1. So your simple interest, your interest rate here is 0.15 divided by is compounding yearly, that is M is 1 to the power. So you've got your time here is not 23. It's only for 13 years. The whole period from N0 to here is 23 years. Yeah? For 23 years, but you are looking for this period, you are saying 23 minus 10, you want for this period. This is going to be equal to your T here, that is your T, that is your T2. Your T here is 13 multiplied by 1. Okay, the value also that is going to be the final value. Okay, your final value is going to be 571. Okay, 1446.59. So I wanted to look at this question for simple reasons, is to help you to attempt at least to write the story into the timeline. The rest of the questions were straightforward. Okay, this one was a simple interest. It is basically straightforward. You start, you end. Here you've got your P, which is this is your T, your T0. Okay, this is where you start at the beginning. Your T1, let me write, this is your T1. Your T1, which is a present tense, your present value. Okay, this is your T0. This is your T0. It has accumulated here. That is your Tn, but you don't know the number of years you are looking for, and then it has accumulated to your future value. That is your S. Your S here is equal to 45 to 100, and then the interest rate here, your I is equal to 0.12. There's nothing a compound diagonal. So when you are going to write this thing in timeline, it's straightforward. Nothing is compounding yearly or monthly or whatever. It is just one interest rate throughout that period. Okay. So now this was very important. So then we can be able to see how you put a story that looks complicated into a timeline. I like to put stories that are complicated into a timeline, Mina. So then I can gather around my thinking. So that is a simple discount, guys. And that is a simple discount. Here is another question. Yebo.
Kule question ogqiba uyenza uyithola kanjani ke ngoku i-answer xa uzifumene zoyi-2 uya plus okanye kule question ogqiba uyenza ye-time,
yeah,
uyithola kanjani i-answer? You add or you subtract kulama answer ayi-2 watholile?
Uqedile nanje. Your final, this becomes your final answer, this one. Ne?
Oh, okay.
What is a common error? I know why you're asking that question. It's easy for you to say, I'm going to take the value here and add the value that I have got here, so then to get my final answer. No. Remember, this one has already been taken into consideration here. So if I get it already, you understand?
Okay.
So you don't say in the end, my answer is going to be S1 and this one. You will get into what we call a circular argument. And I think answer ikona lana, because remember, with multiple choice, you always find your incorrect answer in the answers. Let's see. 571 1446,59. I want to check if ever you are adding these two. 9276,05. 572, but ayikho shem.
Oh, okay.
Is that right?
Mina.
All right. Emma? 92,876.05 plus 571,1446.59. 580. Okay. Ayikho answer which would have made you happy what you've got the correct answer, whereby you add this and that. Be careful. Remember, this amount, you don't need to go back and add it again in this one because it's already been taken care of. Here is the answer. This is where it goes. You are done with this one. You take it to this position. You are integrating it. It becomes your new present value. So this becomes your final answer.
Okay, ma'am. Thank you.
Yeah. So this is one of those straightforward ones. The only thing here is when you'll be it's when you'll be it's when you don't know how to read the context. So what I'm going to do, if you find yourself that you are struggling with reading the context while you are busy with your assignment, drop me an email with a question that because I'm going to tell you, when I was doing my PhD, I was struggling with English so much, until I met a colleague of mine from Indonesia. She told me I must write in Xhosa. Then I started writing in Xhosa, the Xhosa that I don't even know any way to write with. But I wrote English Xhosa, write whatever I wanted to write. Then afterwards, I went to translate it into English. Then from English into academic English. So it took me a long time. So I had an academic English, whereby academic dictionary from simple English to academic. So should you find yourself, Guti, your English is failing you, you cannot read the context, drop me an email and say, hey, Mina Manje, I don't know what is this thing. Here is my email address. It will be helpful when you send me, you are contacting me, send me what is troubling you. Then I can be able to help you to decontextualize the story. Ane? Okay. A simple interest, I don't think this one would give you a problem. Remember, we are using a formula. R is equal to D into 1 minus, what is that formula? What is that formula? I forgot about it. Have you written it somewhere? 1 minus dt, that formula, that's the one you're going to be using here. So your D here is equal to 0,205 divided by 1. What are they looking for here? If the simple interest rate is 24%, simple discount, then the time, or you're looking for the time, your R is 0,24. Your D is equal to 0,205. What is your time? You don't know. Okay, so here what you do, you just simplify for your T. So you've got 0,24 into 1 minus 0,205. T is equal to 0,205. So you can just simplify for your T. Let's look at this one. Richard needs 30,000 for an overseas trip. How long will it take him to save money towards this amount if he deposits now? So now your P here is equal to 25,000. He needs a money for the future of 30,835,42. How long will it take? We don't know. Ne? If he into a savings account earning, your interest rate is equal to 0,105. compounded weekly, your M is equal to 52. You are told it's compounded, so you don't need to be stressing and worrying yourself. You are looking for T. The minute you see that you're looking for your T in a compound interest formula, you must know we are going to use analogs. So your S is equal to P into 1 plus I over M, G. What is your S? Your S is 3835,42. What is your P? Is 25,000 into 1 plus 0,105, ne? To the power, what is your M over 52, ne? To the power 52. This is 52 T, okay? You find that here you are going to have, if you are going to divide your left-hand side with 25,000, I always advise, ne, to try not to cut off decimal numbers, maybe to the second decimal place, especially if you are going to be using logs. You can easily get into an error. Ne? So if you can leave so many decimal places, that's even better. So this is going to be 1,002019 to the power 52T. So here you're going to use that thing of Y is equal to A to the power X. So your X is equal to log of Y over log of A. Okay? So that's what you would apply here to get your 52. To get your T. Okay? That means your 52T is going to be equal to log of 1,2334168, okay, divided by log of 1,002019. Then you plug into your calculator and find your T. So here, Aziza anciently needs 10,000, ne? The bank agrees to give her this amount now, okay? This is now. So now your P here is equal to 10,000, ne? To be paid back 7 months from now. So your T is equal to 7 months. That means it's lesser time. So you want to convert this thing to become an annual period. So you divide by the number of months, that is 12, on a simple discount. So your D is equal to 0,164, okay? The amount that she will have to pay back equal to kufunwa u-S laphayana. What is the formula? Uyayibona nje ukhuluma nge-simple discount. So now the formula that you are going to get is for a simple discount, okay? A formula for a simple discount, your P is equal to S into 1 minus DT. So this will be the formula that you are going to apply. All right, to get your S. What is important is to decontextualize what you are given, write everything down, what the formula are required to get the formula, and then you do the substitution. Okay, the number of years that it will take 6,000 to accumulate to 9,000 with an annual interest rate of 8%, compounded every 3 months. This is interesting. You are looking for T, awuyazi. It will take for this one, this is your P, which is 6,000. To accumulate to 9,000, your S is equal to 9,000. An annual interest rate of 0,08 which is compounded every 3 months. How many times per year? How many 3 months periods do you have in a year? You've got January, February, March, that is first 3 months. April, May, June, that is the second 3 months. July, August, September, that is the third 3 months. October, November, December, that is the fourth 3 months. In other words, when they're saying every 3 months, that means quarterly. This thing is compounding 4 times because you've got a group of 4 threes. It's 3 months, 3 months, 3 months, 3 months. So that's how you know Guti, your M is equal to 4 and not 3. Ne? Not 3. Don't get into that and think, oh, this thing is compounding every 3 months, therefore your M is equal to 3. If ever they say this thing is compounding every 2 months, yeah? How many 2 months do you have in a year? You've got 2, 4, 6, 8, 10, 12. You've got 6 2 months. So your compounding periods, that means your M is going to be 6 in that case, not 2. All right. If you think that is, you are struggling with the compounding periods, you have a reason to contact me and have a one-on-one session. Okay. That was the last one, guys. Ne? Okay. I'm okay, guys. It is goodbye. Let us sign off.